Okay.
Let's see, does it work? Yes, it does.
Yeah, welcome John Arlinger Skogforsk.
Thank you very much. This presentation is a presentation of a draft proposal, a preliminary draft proposal for handling mechanized forest regeneration data within the Stanford framework. And the objective here is to give you a very brief outline of the proposal as it looks like today, and hopefully afterwards getting feedback and perhaps a few critical questions and comments. The Stanford standard makes it possible to exchange data with forest machines. For example, sending an instruction to a harvester, getting production data and operational monitoring work times back from the machine. And it all started in the mid-80s with the harvester and the first optimization softwares introduced. Forwarders added, included in the framework 15, 16 years later, being able to report what has been unloaded at the roadside. The global interest in this type of standard has increased quite dramatically last decade. So a couple of years ago, we introduced a number of tree length machines into the standard framework as well. The standard is to a very large extent driven by the market. And a couple of years ago, I started getting questions and comments from different corners of the world regarding an interest in having standardized data also from machines carrying out planting and ground preparation. It's important to point out that to implement in the standard is one thing. The next step to implement it in the machine, that's up to the market, basically. The manufacturer must see a need for this type of standard. A lot of the building blocks that we need are already in place. Solutions for communication exist already today, and the standard as it is today has a lot of structures included, especially identifying a machine, a work site, an operator, etc. And it also includes a structure for registering the movement of the machine using a tracking structure. And this is an illustration of a quite modern harvester final felling up in this northern part of Sweden. The green lines, the machine movement, and the yellow dots, the position of the felled trees. And if you look at it from a data point of view, a data structure point of view, shouldn't be much of a difference between a planting machine and a harvester. A seedling and a tree, the major difference is the size. Another example, in this case, from a forwarder, including also timestamps, making it possible to calculate velocity of the machine, which was used to categorize the different types of work. And there are, again, you can see quite a lot of similarities between an ordinary scarifier in Sweden versus the forwarder. An early question I asked myself when starting this was whether to keep the information from the planting versus ground preparation as separate information flows, separate messages, separate files. But when looking at the quite large amount of different types of machines existing, I noticed quite quickly that a majority of the machines will carry out both types of work, and therefore it doesn't make sense to make more than have one information flow that can include both both planting and ground preparation. What we did was try to categorize different types of work into continuous work versus intermittent work, where the intermittent work is typically you create some type of point, while a continuous work means creating a line. If we look at the data, I'm not showing you any XML data at all, just a broad outline of what data we include. The idea is to always have the possibility to include the machine movement, and on top of it, we describe the actual work that has been done. In this case, intermittent scarification using 3 different attachments, and we connect each of these rows with points to a specific attachment. You could have 2 attachments or 1 attachment, but using the same structure. Of course, the same structure can also be be used for continuous work, where we basically create lines that has been scarified in this case. We also have to look at it from having other types of machines, simpler machines like this mulcher, where the attachment is actually moving exactly the same position as the base machine, which means that maybe in certain cases we don't need to exclude anything else than the machine movements. Another example, in order to try to illustrate that we do want to also be able to follow the machine movement, both when the machine is in work and when it is not working. And that we, when working, try to include both the position of where the attachment has planted and where the machine is at the moment. Seedlings, a lot of detailed information, of course, position, time, species. We also want the reference to which attachment was used, being able to include an identity. Today, perhaps a batch number, but in the future, possibly an identity on the individual seedling. Also including the possibility to specify if we've used irrigation, fertilization, spraying, and perhaps climate factors. Also have been raised the idea of including information of whether some failure occurred or not. Typically, if you hit a rock or something like that and is not able to do the planting correctly. Final slide. A new standard like this will hopefully make it possible to report detailed production data, giving high quality feedback to the forest owner, and give new possibilities to follow up the results and perhaps plan the next silvicultural step. Thank you.